Okay guys, today we're going to talk about logarithms and their properties. So this should be a refresher from Algebra 2. So first let's re-go over the definition of what a logarithm is. So I like to use a little saying when we're doing logarithms. So if we have a log with a base c of b and is equal to a, we can rearrange that into c to the a power is equal to b. Now this is our log form, and this is our exponential form. And these are equivalent. Now, my little saying is I like to say that this is the backwards alphabet. Because notice how it's C, then B, then A, and I call this one the cab form, like a taxi cab. So, it'll help you remember which letters go where. So, let's practice using our definition just to make sure we can switch between the two forms. So, here's example 1. Okay, we're going to say write in the other form. Okay, so let's take a look at this one. We have log base 3 of 9 is equal to 2. So this is our logarithmic form. We want to switch it to our exponential form. So I'm going to go in here and I'm going to label them. This is C, this is B, and this is A. So this is our backwards alphabet. So we want to switch it to cab. So we want C to the A power is equal to B. So that is 3 to the second power is equal to 9. And there's our other form. That's our exponential form. Let's do another one. So let's do 2 to the 6th power is equal to 64. So this is our exponential form, and we want to change it to our log form. So this is C, this one's A, and this one's B. So this is in cab form, and we want to switch it to the backwards alphabet. So we want log base C of B is equal to A. So from this, we get log base C, and our C in this case is 2, of B, which is 64, is equal to A, which is 6. So switching back and forth between the forms isn't too bad. We are going to use this especially when we start solving logarithmic equations. So this is just simply using the definition of a logarithm. So the next thing we want to talk about are these properties of logarithms. And I've got them listed out here for you. We have 3 properties. We have the product property, the quotient property, and the power property. Now, this allows us to expand and condense these expressions to get what we need from them. Sometimes we need to solve them, and sometimes we just need to rewrite them in a different way for one reason or another. So the first property we have is the product property. So if you have a log with some base C, doesn't matter what the base is, it could be 7, it could be 1,000,000. If you've got 2 things inside that are being multiplied, so we've got just 2 random letters, m times n, that we're multiplying on the inside. Hence why it's called the product property. Now, the product property says that we can rewrite this as log base C. Notice how the C's, which is our bases, have not changed, of m, so we have the first one. Then we're going to add to it log base C of n, which is the second one. So the product property can be split apart by using addition. Now, similarly, if you were given this expression, you could rewrite it just like that. using the product property. It goes both ways. Next is the quotient property, which is really similar to the product property. Quotient means that we've got some log of base c where we have some m divided by some n, some random numbers and letters. It says that we can break it up with log base c of m, so the numerator goes first, minus log base c of n, which is the denominator. So that order is very important. You can't flip them. Because remember, subtraction is not commutative. We cannot flip-flop and say log base c of n minus log base c of m. That would be wrong. Now, similarly to the product property, if we were presented with this expression, we could use it to rewrite it that way as well. The last property is the power property. You have log base c of m, and this is to the power of p. That's why it's called the power property. So you have an exponent here. What that says is you can take this p and you can put it in front of our logarithm. So we have p out in front of times log base c of m. Now, just like the other ones, if you're given this expression, you can rewrite it this way. So next, we are going to use these properties to expand and condense some expressions here. Now, when we're expanding, that means that we're taking a single log and we're writing it out with as many logarithms as possible. And when we're condensing, we're taking a big long expression and we're trying to write it as one logarithm. Okay, so on to example 1. We're going to expand some logarithmic expressions. So let's start off pretty simple. If you have log base 7 of 3x. Now notice what's inside the parentheses here is we have 3 times x. So if we have multiplication on the inside, we're going to then use the product property. So let's go ahead and use the product property on this one, because 3x is the same thing as 3 times x. So we can split this up. Log base 7 of 3. Remember, we put a plus when we're using the product property. Log base 7 of x. And we have expanded that as far as possible. There's nothing else we can do to it. Okay, let's look at another one. With this next one, we're going to have things that are a little bit more complicated. We have log of x over 3 to the 5th power. Now, if you notice, I did not write a base here. Now, let's make a little note up top. If no base is written, it is 10. Now, it's just understood to be 10. It's just like whenever you have an x, it's understood that you have a coefficient of 1 in front of it. So, what we have here is log base 10. But quite frankly, the bases really do not matter on these. So if we take a look at this problem, we have two things going on. We have a power, and we also have quotient. Now, we got to be really careful. We need to decide which one we're going to do first. The first one we want to do is the power. So we're going to take this 5 and we're going to put it in front of our logarithm. So we have log base 10, which we don't have to write, of x over 3. So we took care of our power property. The next thing we want to do is take care of our quotient property because we have division here. Now, with this, we've got our 5, and it's going to be multiplying everything that we are doing with our quotient property. So we're going to have a 5 on the outside times log of x, so we take the numerator, minus log of 3, which is the denominator. So far so good. We've used our two properties. And the last thing we need to do is simply rewrite this by distributing the 5. So we have 5 log of x minus, then we have 5 times log of 3. And we've expanded that as far as we can go. Let's do another one of these. So we have log base 2 of, we have 3 over x y to the 7th power. So we've got a lot of things going on in this one. We have a power, so we're going to have to use the power property. We have division, so we're going to have to use the quotient property. But if you look in the denominator here, we also have multiplication, so we got to use the product property. So whenever you have the power property, you want to go ahead and take care of that first. So we're going to take that 7 and put it in the front. We have 7 times log base 2 of 3 over xy. Now, if you're faced with a situation where you've got product property and quotient property, try to take care of your quotient property first. So we're going to have the numerator minus the denominator. And then we can go back and split up that x and y. So here's where things get a little crazy with our signs. So let's use the quotient property. We have 7 times log base 2 of the numerator, which is 3, minus log base 2 of the denominator, which is xy. So I'm going to put those in parentheses just so I understand that I'm taking the log of both x and y, the product of it. Then I'm going to close my parentheses here. So now we need to go back and we need to use the product property with this expression right here. So 7 times log base 2 of 3, I haven't touched that, minus, and we need to use parentheses here, log base 2 of x plus log base 2 of y. Okay, so you see why we're using some parentheses? Because this sign right here is going to do some damage to this one behind it. So we have 7 times log base 2 of 3, and let's distribute this negative, minus log base 2 of x minus log base 2 of y. And the last thing we need to do is distribute out that 7. 7 times log base 2 of 3 minus 7 times log base 2 of x minus 7 times log base 2 of y. And that'll be our final answer. We've broken everything up as far as possible. And we've been really careful with our signs. So that's how we expand these logarithmic expressions. Now we're going to condense some of these. Let's take a look at this one. We have log of x minus 3 times log of 2. Okay, so we've got a couple of things going on here. If we see this minus sign, we're going to have to do the quotient property. And if you've got a number in front of a logarithm, you need to do the power property. But notice that this 3 is only in front of this logarithm and is not in front of that logarithm. So only this 2 is going to get raised to the 3rd power. So let's take care of our power property first. So we have log of x minus log of 2 to the 3rd power. So we used our power property to bring that 3 up as an exponent. Now we are going to use our quotient property because we have this minus sign here. Now this is going to be our numerator and this is going to be our denominator. So we have log of x over 2 to the 3rd power. And that's our final expression. So we took 2 logarithms and we condensed it into 1. Let's do another example. For this example, we have 5 times log base 4 of x plus 5 times log base 4 of z. So for this one, unlike the first one, we have a number out in front of both of them that's the same. That's going to come into play a little bit later. So let's go ahead and let's take those 5s and let's make those exponents. So we're going to have log base 4 of x to the 5th power plus log base 4 of z to the 5th power. So we took both of those numbers in front and made them exponents. Now, what we have here is we have an addition sign, which means that we're going to use the product property. So we're going to have a single log base 4, and this time we're going to multiply inside of it x to the 5th times z to the 5th. Now, although we've already condensed that to one logarithm, this wouldn't be incorrect. It's actually 100% correct. But if you notice how both x and z are both to the 5th power, we can rewrite this as log base 4 of x times z to the 5th power. Because if you re-expand this, you'll get the same thing. So either one of these works. More than likely you'll see it this way though. So let's do one more example of condensing. So in this case we're going to have 3 terms. So I have log of y plus 2 times log of x minus log of z. So we got 3 logarithms this time. Only one has a number in front of it. So we're going to go ahead and take care of this 2, and we're going to make it an exponent. So let's rewrite the expression. So we have log of y plus log of x squared minus log of z. Now here's where we run into maybe some confusion. Hopefully not. We're going to use product property there and quotient property here. But the question is, which one do you do first? Well, honestly, it does not matter which one you do first, as long as you're being careful with your signs. I like to go from the front to the back. So I'm going to group these 2 together, and I'm going to go ahead and use the product property because we have addition. So I have log of, and I'm going to multiply y times x squared. So because I like my variables to be in alphabetical order, I'm just going to put x squared y. Then we still have minus log of z. So now we've taken it from 3 to 2. Let's take care of this minus, which means we're going to use our quotient property. So this one's going to be your numerator, and this one's going to be your denominator. So we have log of x squared y over z. And that's our final solution. Using these properties is going to help us whenever we start solving logarithmic equations. So let's get used to bouncing back and forth between the forms.